topics that are left out in pointer. Okay, so in last class we learned about pointers. Int, star, ptr. So we use star to indicate that this particular variable is a pointer. Say that's how we learned it, right? And then if it is pointer of pointer, then it would be written as star star, the name of the pointer or variable, right? And then we learned about pointers and array, right? So in pointers and array, we saw that by writing the name of the array, it is in fact is a pointer that points to the address of the first element in the array. So it is equivalent of writing n% of data of 0 or element of 0, say, right? Okay, so I was saying pointers and array. So in pointers and array, we saw that by writing the name of the array, it points to the first element in the array, right? Okay, so today we will look at multidimensional array. Okay, what happens if it is multidimensional? How we can define the array, okay, in terms of multidimensional array. Okay, so multidimensional array can be expressed in terms of an array of pointers. Okay, so when you define the multidimensional array, by using the pointers, okay, by using the pointer, we can define the multidimensional array as one-dimensional array. So we can use one-dimensional array. So this is the conventional way of defining the array, right? We write data type, then name of the array, then rows, column. So this is how we write it, right? For example, let's say int, then you write a, right? Then row, let's say it is 3, then let's say our column is 4. That's how we define the our array, right? But now if we want to define, okay, the array in terms of a pointer, then we will write it as, let's say int, then star, name of array, let's say a, and then we just write the rows. We don't have to define the column. So this is in fact similar to one-dimensional array, not two-dimensional. Okay, so this two-dimensional array can be defined as one-dimensional array if we want to define it as a pointer, in terms of pointer. Okay, so for example, let's see, this is our array. Okay, so if you are supposed to define array, okay, two-dimensional array of size, okay, rows, 3 rows and 4 columns. So if you want 3 rows and 4 columns, okay, then we can define this array as, okay, int star, then name of your array, and then how many rows. Okay, so here when you write, okay, int star x of 3, okay, so when we write x of 0, it's similar to the array and character, okay, string, x of 0 will point to the beginning of the first row in the element. So let's say, for example, your array is, let's say, of size, let's say our actual array is, let's say, int x 3 4. Okay, so let's say this is our actual array. Now we want to store this array. Okay, so by defining as a pointer, we can write it as int star x of 3. Okay, so by writing a, okay, let's say x of 0, so this one will point to the first element. This one will point to the first element. Okay, so it is equivalent of writing x of 0 0. Okay, so now if I want to, so x of 0, okay, will hold the memory address of the first element in the array. Multidimensional array can be defined as one-dimensional array by using a pointer, right? So if this is our array, okay, which is defined in terms of pointer, then by writing as, okay, x of 0, it points to the first element of the array, which is x of 0 0 in terms of our array. So let's say our array is 1 2 3 4, then 5 6 7 8 9 10 11 and 12. So this is our array. So we have 3 rows, 1 then 2 and 3, and total we have 4 columns. So we have 3 rows and 4 columns. Now we want to, okay, print, okay, so by saying x of 0, it will point to this one, the first element, which is this one. So that is x of 0 row 0 columns. Okay, now if I want to, so this one just points to the address, okay, address of this first element. Now if I want to print the value, so I have to write the star. I hope you all remember this one, star of x of 0. So star x of 0 will be the first element, the actual value in the first row, first column. Is it clear, everyone? Okay, then now if I want to display the second element, then that would be, so this one would be, okay, this one would be x of first row plus 1. Okay, and then to print the value, it would be star of x of 0 plus 1. So it is equivalent of writing x of 0 row first column, sorry, second column, 0 1. Then similarly, x of 1 will point to the second row, x of 1. Okay, and then if I want to print this one, it would be x of 1 plus 1. This would be x of 1 plus 0. So x of 1 0 can be represented by x of 1. Now if I want to print the value, okay, this one would be printed as star x of 1. So this one will print the value 5. Okay, and now if I want to print the value 6, then it would be x of 1 plus 1 star. This will print the value 6. Is it clear, everyone? Individual array element such as, okay, x of 2 3 can be accessed by writing this one, that is x of 2 plus 3. So that indicates it is in the, okay, row 2. Okay, 0 1 2. So that is, it is the third row, and then this is the fourth column. Understood? So in this expression, x of 2 is the pointer to the first element in row number 2. So 0 1 2. Okay, if it is 0 1 2, if it is started from 0, then it would be third. Otherwise, it is in the row number 2 if it starts from 1 2. Okay, and then similarly, this one, x of 2 plus 3, okay, will be pointing to the fourth element located at the 3 within the row number 2. Okay, so it is equivalent, this one is equivalent of saying x of 2 3, second row, third column. So let us look at the example to understand better how we can use the array. Okay, so in this example, okay, we have defined m and n. We have two value, okay, m and n, where m is 2 and n is 2. So we are going to create an array that displays 2 by 2 array. Okay, so in this example, we are reading the array, okay, from the user. So this one from the outer loop for the rows, and this one inner loop for the column, right? Okay, so then we write print x of, okay, this value, which is I. Okay, so this is a row. Okay, so x of 0 first indicates x of 0. Okay, scanf will read the value from the user. So we have first, okay, x of 0 I entered number 4, then x of again 0, we are still in same, okay, same row I, we are in still same row, okay, so that indicates we are in row number 0, okay, that's our row, but then column changes. So initial j is equal to 0, okay, my value was 4, then again my column increments, j becomes 1, and I enter the value 6, okay, and then again after this one n is 2, so next increment 2 by 2 less than 2, so it will go out of the loop, and then I'll be in the next row, so my value is 1 here, okay. So here what I'm trying to do is I'm just reading the value from the user, okay. Here next, so in this example, okay, I'm going to display the array now. So here if you have seen, I've used the pointer, okay, to enter the value x of I plus j. So first initially x of I, okay, x of I points to, okay, x of 0, so that is row, 0th row, right. Now if I have to move on to next column, right, so I have, okay, 4 6 7 2, so this one is 0 0 0 row 0 column, right. So x of 0 points to the first one, right. Now if I want to, okay, enter the value of the second one, that is it should be 0 1, so that's what I did here. X of I is 0 0 plus, now j increment, first 0 is j is 0, so it is 0 0, so x of 0, okay. Next time it increments I, x of 0 plus 1, so it will point to number, this one 6, so it is equivalent of saying x of 0 0, okay. So in this example I was saying, now to display, so we require the value, we want to display the value, so this is what I'm displaying, okay, the value. So we have to use the star, and this is again same compared to this one, okay, it's similar to this one. So when I is equal to 0, when I is equal to 0 and j is equal to 0, what is the, okay, this one will point to the address, right. So this is x of initially I is 0 plus 0, okay. So that means it is equivalent of saying 0 column 0 rows, yeah. So which is stored as 4, right. And then by writing star, it will point to the value which is 4, so I have 4 printed. Again it goes increment, j becomes 1, so I have 6, okay, then 7 and 2. So that's how we can use the pointer, okay, to display the array, the two-dimensional array. Another example, this is regarding with one-dimensional, okay. In one-dimensional, how did we use one-dimensional to, okay, read and then scan, I mean display the value. So we defined, okay, a pointer variable, okay, then we assign the value, right, ptr is equal to x, that points, so when we write it like this, ptr is equal to x, so this one indicates, it points to the x of 0, right, n% of it is equivalent of writing n% of x of 0. If you all remember in our previous class, we said that writing x, so this is the name of the array, by writing the name of the array, it will directly point to the first element in the array, okay. Then this one is how I read the array from the user, okay. Percentage d ptr plus j, so ptr is equivalent of writing n% of x of 0, right. Then when j increments, j, when it was 0, I have plus 0, so it will point to the first element, j increments, then in the second it would be j x of 0 plus 1, right, it would be, sorry, plus 1, so that is x of 1, n% of x of 1. Okay, then in this example I'm displaying, so same again, use the star to print the value. So this one will point to the address and this one will point to the value in which address it is stored. So we have been learning about pointer. We saw that we can use pointer to store the address of the value of the variable, right? So what is the advantage? Okay, why we use pointer? Let us see. Okay, how this pointer helps. So the importance of using the pointer is, okay, let us consider the following array of string. Let's say char name 325. So 3 is the row and 25 is the column, right? So that indicates in terms of string, we can also read it as there are 3 names, right, with a maximum of 25 character, maximum length of 25 character in each name, right? That's how we can read it, right? So in this example, the total storage requirement for the name of table is 75 bytes. Okay, we know that rarely the individual string will be of equal length. That is also true, right? All name cannot be same size, right? Pema must be larger than the ohm, right? The number of characters must be more in terms of string than ohm or pem, right? So no name can, okay, it's possible to have similar, but in most of the case we cannot have equal length in all the names, right? Therefore, instead of making each row a fixed number of characters, we can make it a pointer to a string of variable length. So let us try and understand this one. Okay, if we use this pointer, so let us assume that, so initially we saw that if it is just a normal variable, let's say char a, then we store it as x, right? It has to be within the single inverted, right? If it is a character, single character, right? But if it is an array, then it would be written as, let's say char a, then you define the size. Let's say, for example, it should be, since it is a string, it should be written in multiple, double quotation. So let's say sonam, for example. So in this case, the memory allocated for the this character, let's say for example 101 is the memory address of this variable. Okay, and then in this case the memory allocation, let us assume that, okay, s is allocated in 101. Okay, if this is an array, then let's say o as 102, since character takes only 1 byte. Okay, then let's say n is equal to 103, then a would be 104, m 105, and finally null 106. So total you require six memory address to store an array which has a variable, okay, or value as sonam. That's what we learned, right? Okay, now let us try and understand if it is two-dimensional. Let's say char name, okay, let's say 3, then let's say 6. So this indicates there can be 3 names and a maximum of character length in the name is 6. Okay, let's say for example is equal to let's say sonam, and let's say pam, and then let's say om. So this is a two-dimensional, okay, 3 rows 6 column. Okay, so if we just draw it, so that indicates there are 3 rows. So S O N A M, null, my first row. Then you have P, E, M, null, second row. Then third I have O, M, null. So two-dimensional, this is 3. So 0, 1, 2. Or I can write 1, 2, 3. It depends on how you write it, right? So I have 3 by 6 two-dimensional array. So here, okay, if we see the memory allocation, okay, this one S, they say, is allocated in 101. Okay, so 101, 102, 103, 4, 5, 6, right? So P would be located in 107, 8, 9, 10, 11, 12. Then O would be located at 107, 8, 9, 10, 11, 12, 13. It would be 113. So in total, space taken is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So total space or memory allocated for this one is 18 addresses. So 18 addresses are required to store this 3 by 6 array of type character. Okay, now let us try and understand in terms of pointer. So let's say char again. Now we define a pointer star name. Okay, so we'll just write the row, not the column. Okay, is equal to, let's say again same. So num, then pam, and let's say om. Okay, so this is my two-dimensional array with, okay, which is defined as a pointer. Now here what happened is, okay, by defining it as a pointer, okay, let's say S is stored in 101. Okay, so 1, then you have 1, 2, 3, 4, 5, null is 6, then P would be stored in 107. Okay, 7, 8, 9, 10 is null, then here it is O, which would be 11, 12, 13. So total number of address would be taken in this case by defining the pointer is 13 address. We will not be taking all. Unlike the earlier example, it was 18 addresses, even if some of the space is not used. Okay, so by using the pointer, so this is the advantage. Okay, memory space are not wasted in terms of pointer. How many memory required will be allocated accordingly in terms of pointer. By using the pointer, you can utilize the memory address or space. You don't waste the memory address. Okay, so this is one example. So if you were to if you were to use the pointer, okay, if you were to use the normal way of writing the array in this example, character name 325, right? The total number of requirement for these this way of defining the array would be 75 bytes, right? We have 3 into 25 is 75, right? In our early example it was 36, so we have 3 into 6, 18, right? So that is a fixed number that is allocated, right? And then by using the array as a pointer, right, we can define, right, based on the requirement. Okay, the pointer the pointer will allocate the memory accordingly. So in this example we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in the first row, then 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, then 23, 24, 25, 26, 27, and null 28. So we require 28 byte in terms of this example by using a pointer. Okay, so that is one advantage of using the pointer. Okay, try and understand. Okay, then to print out the array, right, name, we can directly write %s and then name of I in terms of the multidimensional, right? Since we have 3, so if it was just a single or one dimensional array, I can directly write printf %s then name, right? But we have 3 rows, right? Since it is a multidimensional, so I have to write %s name. So here, when I say name of 0, it will print the first element, the first row, right? If I say name of 1, then it will print the second element, second row, that is Australia. Okay, and then name of 2, third row, which is India. Okay, that's what I did here. Name of I. So if it is 0, first row, and name of 1, name of 2. Okay. But if you want to print one by one, if I want to print N, then E, then W, then Z, then E individually, then you can say name of I plus J and then star individual. Then instead of writing %s, it has to be %c. Okay, %c name. Okay, star name of I, that is the row, and then plus J is the column. Okay, so first row, first column, first row, second column, so it can be printed. So this one would be first row, okay, first column, then E, first row, second column, and then so on. Okay, okay, let us try and understand how, okay, what is how the pointer is advantageous to to create the array on allocating the memory. Okay, try and understand this screen. So we have pointer CTPTR created as a one-dimensional array, okay, which is in fact a multi-dimensional array. We have 1, 2, 3, 4 rows. We have 4 rows here, and okay, the column has not been defined. Okay, now to print the value. Okay, so here what I'm trying to do is printf value of p of this one is %u. So if you all remember, I said you can also write %d is also fine. So %u indicates unsigned integer, right? So like if you all remember, I said that memory address does not have sign. It cannot be positive or negative, unlike integer. That's why the correct way of displaying the memory address would be %u. Okay, so here first is r, that is when r is equal to 0, p of 0. Okay, and it can go until 4. Then %u is the CTPTR r. So this is the value which shows the address. So this is a pointer that shows the address of, okay, this one shows the address of CTPTR. So initially r would be 0, so it will be pointing to this one. So when we write CTPTR of 0, so that means it will point to the first element. Okay, CTPTR of 0. CTPTR of 0 is the address. Okay, it's address that points to the first element. Okay, first element of row 0. So that means this one will point to C. So this is my row 0, right? So this will point to C. Okay, now if I want to point to H, then it would be CTPTR of 0 plus 1. Okay, so this will point to H. To print the value, it should be written as star. Okay, star of this one means then it will point to C. Okay, and star of this one means it will point to H. Okay, so when I write here CT of PTR of 0, PTR of R means it points to the C. Okay, so initially CT of PTR of 0 would be the address of where the C is stored. Then CT PTR of 1 will be the address of K, not whole Kolkata. Okay, just K. Then if you want to print whole, then you have to write one by one, or you can write percentage S will display the whole row. Okay, if it is percentage C, then you have to write CT PTR of 0 plus then 1, 2, 3, and so on. So this one will display the value, okay, as this. Okay, so value of P of 0 is, okay, this is the memory address. So percentage U shows the memory address, which is CT PTR of R. So that's one. This one shows the first memory address of the first element, that is 0, 0, 0 row, 0 column. So this is C, the memory address of this character C. So we have 88, right? Then we have 88. Okay, then next is H. So 89, 90, 91, 92, 93, 94. Null is 95. Then next is K, so that is 96. So immediately it points to K. Then again same, 96, 97, 98, 99, 100, 101, 102, and null is 103, then 104, which points to M, and so on. Okay, so memory is allocated one by one immediately after, instead of wasting the memory. So this one is displaying the memory address of each row. We saw that it stores the memory address of the first element of each row, right? Now let us try and understand, okay, if you want to display one by one, okay? So you have val star PTR, okay? Val star, that means that indicates the value of this one array, okay, which points to the, initially if it is R is 0, it points to the first element, first row, right? Plus C is not equal to null. So we'll go on until, okay, it is null. Okay, printf percentage C is in the address percentage U. So percentage C value. So we write star CT PTR, okay, of R plus C. Okay, comma, and this is address. So we don't write the star. We just write this one. Okay, if you want to print the value. Sorry, the address. Okay, let us see the output. So we have C, okay, is in address 88, then H 89, okay, then 90, 91, 92, 93, 94, and next is null, so 95, then go on next 96, 97, 98, and then go on. So this is one advantage of, okay, the pointer, where I said that you don't have to the memory address are not wasted in terms of pointer. We can immediately assign the value, unlike the conventional way of assigning the address or memory, right? The early example, name, where Pema and Om, both of them may not take the same size, right? Pema will take more address, whereas Om will take only 2, right? So accordingly, okay, accordingly in terms of pointer, we can assign the address. Okay, so this is one advantage of using the pointer. Okay, another advantage is dynamic memory allocation. So dynamic memory allocation, we can define the array, okay, int array of 10. So this is the conventional way of defining the array, right? This is a one-dimensional array. So here, by saying int ARR10, I'm telling the compiler that this is of type integer and the name of my array is ARR and the size is 10. The size is 10, that indicates, so by default, in terms of character, we saw that the memory byte allocated is only 1, right? 1. But in case of array, it is 4, and sometimes 2. So it depends on the which type of array, the integer you use it. Okay, long or the shorter one. So here, int AR of 10. Okay, so when the compiler read this 10 as size of 10 into 4 byte or 2 byte, okay, will be allocated to this array. It will be fixed. Okay, so this memory address would be allocated to this variable array ARR, and then when the value is entered in this address, the value would be stored. Okay, so this is a conventional way of defining an array. Okay, so now we can look at the pointer. We can also define the array as a pointer variable. Okay, we can use the pointer variable to function similar like an array. Okay, so we can use a pointer variable int star ARR rather than defining int ARR of 10. So here we have defined the size. Here we have not defined the size. It's just a variable. A variable has been defined. Okay, so we can use this pointer variable to represent this array. Okay, so a conventional array definition results in fixed block of memory being reserved at the beginning of the program execution. So here 10 memory 10 size 10 is reserved as a block of memory. Okay, whereas this does not occur if the array is represented in terms of pointer variable. So if it is defined as a pointer variable, then we don't have to define the size. Okay, let us see why. Therefore, the use of a pointer variable to represent an array requires some type of initial memory assignment before the array elements are processed. So this process of allocating memory at runtime is known as dynamic memory allocation. So we, instead of defining at the initial stage like this, defining the size, we can define when, it is at the runtime, when it is already being executed, when the execution is already happening, we can define the memory allocation. We can define or we can create the memory allocation. So this process by defining the memory allocation at the runtime is known as dynamic memory allocation. We define it in dynamic. That means accordingly on required. We don't assume the size and then define it. We will accurately exactly create the memory required for that particular variable. So to do that, there is a library called malloc, that is memory allocation library function. So this is a function that is used to dynamically allocate memory for the array of pointer variable. Let us see how we can do that. Example, suppose X is one-dimensional array and then we require 10 elements of array to be stored. So we can write, define the pointer variable that is int star X rather than, instead of typing as int X of 10. Then we can assign the memory allocation dynamically. So we will use this malloc function. Malloc function. So X, we want to define the, we want to make this our X, this X similar to this one of size 10. But then when we define it like this, we have not defined the size of the array. We have just defined the variable that is of a pointer variable. So by defining like this, X is equal to, now to this variable X is equal to, this is a syntax how we can allocate the memory dynamically. So int star, then malloc, this is a function, malloc function, malloc 10 into size of int. So this one data type depends on which type of data you have created. So here my data was int, so that's why I write it int. So if it is float, then you have to write it float, or character, then it has to be character. So int start, that indicates this is a pointer, and then I want to dynamically allocate my memory. Okay, and then to do that, I use this function malloc. So how many size I want to store it. So let's say I want exactly 10, then I can say 10 into size of int. So size of int, it depends on how many allocated for your system, your compiler, how many it takes. So if it is character, then it would be into 1 byte. So if it is integer, it can be into 4 byte or 2 byte. Okay, so this function reserves a block of memory whose size in byte is equivalent to 10 integer quantities. Okay, let us look at the example how we can use this. Okay, let us try and understand one program. So this is a program which reads and print one-dimensional array. Okay, and then the size of the array is specified at the runtime, not initially defined. So in here we have not defined the size of the array. By the way, when you use this malloc, malloc function, you have to include it from this page. So this is a header file. So studio, we have already learned, right? Studio, when we use the studio.stdio.h, we use it for, since we are using these two functions, printf function and scanf function. So when we use these two, we have to include this file, right? That means it is being imported from this file or borrowed, right? So this malloc function, it is also, it is retrieved from this file stdlib.h. So if you are using this malloc function, make sure that you include in the header this file header. Okay, so now I've defined three variables. One is pointer variable, then I have n and I. How many array element you want to enter? Percentage d, scanf, and %n. So this value will be stored in my variable n. So let's say, for example, I've entered how many array element I want to enter. So I'm saying 5. I want to enter 5 numbers of element. Since I have not defined the array size, now I can, so based on this so initially let's say I have defined int array 100, and then I record only 5, then that is a waste of memory address, right? So what I can do is, I can create the size of memory, at the runtime, when according to the user's requirement. So here my user wants only 5 memory, 5 element to be stored instead of 100. So I don't have to define 100. So I can directly say, so this is how I can allocate the memory at the runtime. So this has already been executed, right? Then I can say ARR. So this is where I'm going to store my array. ARR is equal to int. So this is a type int. So int star, then memory allocation n is the value where the user enter 5. So 5 into size of int. Now this array is allocated with the memory of size 5. So this is how we can allocate the memory at runtime instead of defining at the earlier time, at the start time, since we may not know what or how many number of elements are required, right? Now let's try and read the array. Read the array element. So printf, read the array element for I is equal to 0, less than n, I plus plus, and then same. That's how we read the array, right? So I'm saying int ARR of 0, scanf ARR plus I. So initially ARR means ARR will point to the 0. That is first element, right? So 0 plus 0 is 0. So that's why I enter the ARR of 0 as 9. So this is how we read the element from the user. So I have ARR of 0 as 9. I've entered 9. then 1 as 3, 4, 5, and 6, right? So when it is here, I is equal to 1, so ARR of 1, okay, would be ARR plus I. So ARR plus, it would be 1, so it will be point to next. So 0, 1, 2, 3, and go on. Okay. So we have entered the, okay, we have asked the user, we have entered the memory, okay, we have allocated the memory dynamically during runtime. Then based on this memory, we have read the array, we have, okay, we have entered the array element to the array defined, that is ARR, right? Then let us try and read the array. So printf, the array is star values. Now we are going to display the values. So star ARR plus I. This is how we display the array. Okay, let us look at another example. So here, how many letters is there in your name? Let's say 5. Okay, that means your array will take maximum of 5 characters. Okay, now, so we have not defined, so we have just defined the pointer variable, that is star name. We have not defined the size. Okay, so based on the user, so if user has 10, then we will, okay, dynamically allocate 10 memory or 10 size. If user has only 3 character in their name, let's say Pam, then we will, okay, create only 3 memory address required based on the user. Okay, so scanf number, we allocate it. Okay, name is equal to, so here I have written n plus plus. So size, let's say the name is Sonam, so I have SONAM 5, right? But I've incremented 1. Can anyone tell me why I've incremented as 1? Since we require not only 5, the 5 is the letter, we need extra null value in terms of string, right? That's why I have incremented 1. Okay, so total is 6. Now name is equal to, I allocate the memory. So star, since it's a type character, right? Then malloc, memory allocation, n. Now n is 6. Here I have stored as 5, incremented 1, 6. So 6 into size of character. So I will have total 6 byte. 1 for the null, 5 for the letter. Okay, now let us read my array. So printf, enter your name. Okay, enter your name. I can directly type Sonam. Read it as a character, string, right? Percentage s name. Then let us display the array one by one. This is how we do it one by one. Or I can directly display it, right? Display as percentage s and then name. If I want to display one by one, I want to see, okay, in each individual. So for I is equal to 0, okay, and then the value of this address is equal to null, okay. So printf, name of 0 is percentage C, that is star name plus I. So I have SONAM and then next one is null, so it will stop at null. So that's how we can use the pointer, okay, by dynamically allocating the memory.